Okay, I'm going to go through an example of creating a correlation matrix in Python, and I'm going to be using some downloaded stock data. This is going to assume that you already have Python and a number of supporting libraries installed, and probably the easiest way to get most everything you need is going to be to install the Anaconda scientific platform, and I have the link for that right here. We're also going to need to install this additional library called Yahoo Finance, and to install that you're going to go out to a command prompt and enter the command pip install Yahoo Finance. Alright, so I'm working in a Jupyter notebook, and this is just sort of a good alternative for displaying things and working interactively. The first thing we're going to need to do is to set up our environment, and that's going to involve just importing several supporting libraries into the Python standard library. Okay, so to run a cell in the Jupyter notebook, you're going to hold the shift and press the enter key. Alright, and you can alternatively press the run button up here in the menu. And I should point out that this Yahoo Finance that I'm going to be using, it's being billed as a temporary solution to these API changes in Yahoo Finance, plus a few of the others. Pandas has a complementary library called pandas datareader, and that allows downloading data from a number of sources. If you want to use that, I have the link here to get out there and read the documents. So what we're going to do is create the correlation matrix as stated earlier, and correlation is a statistic that evaluates how closely two variables move together or in opposite directions, or even if they're related at all. Alright, so it ranges in value from -1, which means perfectly negatively correlated, as one increases the other decreases. Perfectly positively correlated is a value of 1, and as one increases the other increases. And then values closer to 0 indicate that there is no relationship, or maybe a weak relationship. Okay, so we're going to go ahead and get some data for the FANG stocks. I'm going to set a variable equal to stocks. I'm going to start with just a string. Then I'm going to split the string. Okay, once that's done, I can go ahead and set a variable to store the downloaded data in. I'll just call it data. And I'm going to use Yahoo Finance, use the download method. We'll download stocks, and then optionally I can put in a start and a stop date. I'm going to put in a start date and go back about a year. And then we really only need the closing price here, so I'm going to put that modifier on the end. Once we get the data, I'll display the first few rows of it. Okay, so it takes just a second or two. It downloads the data, and then we can see what we ended up with. Going back to June 1st, about a year ago, we have the closing price for the 5 securities that we're looking at. And I should mention that I included gold. It's not really a FANG stock, but I included it just for comparison purposes. Okay, if we want, we can get a quick plot of these 5 securities, and to do that I'm going to need to import another library, so matplotlib, and then I'm going to use this magic function so that the plots we generate are shown right in our notebook. Once it's imported, we can go right into plotting. I'm going to add the legend here so we can easily identify which security is which. And if you notice up here, even though I put them in the correct order, when we download the data, Pandas sorted it alphabetically. So I'm going to, if I want to label things correctly, I'm going to need to put it in the order that Pandas has it. I'm going to set it to appear in the upper left corner with loc2, and then run the cell. Okay, so we get a nice little graph. Sort of difficult to identify from this if any of the stocks are related in their price movements day to day. So we're going to need to actually transform the data before we can see if there's a relationship. So to transform the data, I'm going to store instantaneous rates of return in a new data frame, and I'm going to call the data frame returns. So I just create an empty data frame frame first. Then what I need to do is loop through each of the securities in our data that we downloaded. Okay, I'm going to add one line of code here that makes sure that we're not adding duplicate data into our data frame. Okay, so we're just going to check to make sure the stock's not already in there. And the reason we do this is because you may come back later and add some securities to your correlation matrix. If I run this cell more than once, the data is going to get added more than once. All right, so that's why I'm adding this one little line of code. Okay, so if it's not in there, then we just put it in there. And to calculate the instantaneous rate of return, I'm going to use NumPy log function. I'm going to look at the data. I'm going to look at the proper column. All right, and then I'm going to offset by 1. All right, so I can use this diff method, which is actually part of pandas. And if you wanted to offset it by, say, 5, you could put a value in here, but by default it offsets by 1. Okay, and that's all there is to it. We'll get a look at that data. Okay, so you can see presented as a decimal, this is close to close change. There is no first row for any of these because, well, you couldn't calculate it. All right, so I'm actually going to go back in and drop off that first row just to avoid any problems. Okay, so this tells it to look at everything from the first row on. All right, one more thing before we generate our correlation matrix. I'm going to look at some descriptive statistics for our returns. And I do that using the built-in describe method, another method of pandas. And it's not terribly useful to look at these, although it does help verify that we do have the same size data set for all of the securities. Again, we need this to calculate correlation. We can note some things that are interesting here. Most of the securities have a average change very close to 0. We can look at the volatility of them and see that, 3 out of 5 of them are very similar. You can also note that the volatility of gold is quite low. Okay, so we're ready to go ahead and generate our correlation matrix now, and we can do this very simply. We call the returns variable and we access this core method again from pandas, and then I just run it. All right, and just like that we have our correlation matrix, and then you can quickly see, okay, in one nice little table how things sort of move together. All right, and I'm just going to pick one. I'll pick gold just because if you look down through here you can see that, well, it's pretty weakly related to everything. And this might explain why people suggest that you have some gold in your portfolio, as it's not going to probably move the same way that other things in your portfolio move. Beyond that, we can look down through and we can see that, oh, Amazon is pretty moderately to strongly correlated with all the other FANG stocks, meaning that a lot of the time they tend to move in the same direction. All right, if we just want to look at a single security, we can do that. Again, we call core and we just call it on the column that we're interested in. And if we want to present it in a little more readable form, we can add this sort values method and ask it to sort in descending order. Okay, so we can see as far as Amazon's concerned, the most strongly correlated security is Google, followed by Netflix, and then, yeah, gold is the most weakly related. Almost no relationship there at all. So finally, you may want to look at this graphically to get an idea of, well, what does it mean when something has a correlation of 0.66 or a correlation of 0.61? We're going to graph all of these together. I'm going to do that with the help from a sub-library in pandas called plotting, and I'm going to import this scatter matrix, and then we just call scatter matrix on our returns. I'm going to set a couple other parameters because I want the graph to be nice and big. That's done with fig size. And then I'm going to set the parameter that gradients the data points so that the most heavily concentrated data points sort of show up darker. That parameter is called alpha, and it can take a value between 0 and 1. Values closer to 0 give you a higher gradient. So I'm going to set it at 0.3. With that done, just run the cell and we get our scatter matrix of plots. Okay, so if I look down the gold column, that's what it looks like to have very close to no relationship. We can see, if anything, it looks like sort of a flat line. but mostly it just kind of looks like a cloud of points with no distinct direction. All right, if I look at Amazon, so reading across this top row here, if I look at Amazon, we can see that, oh, it looks like things tend to move upward and to the right. So as Amazon is going up, it looks like Facebook also tends to go up, although the relationship's not perfect. All right, we can see similar stories with Google and Netflix. All right, so the top half of the graph puts Amazon here on the y-axis, all right, with the other securities on the x. And if we look at the lower half, it plots them in the opposite direction in case you want to see what the graph looks like in either direction. Okay, so I hope that helps with correlation matrices in Python.